Hi and welcome back to my channel. This week's problem is to find out the length of PQ. Now what we've got here is a regular hexagon with a regular triangle aligned with the top side of that hexagon from A to B, and we know that AB, so the length of the hexagon, is 1.5 times the length of the equilateral triangle PQR. We're told the shaded area is 72√3. Can we work out PQ? That is the side of the equilateral triangle. If you want to solve this problem yourself, this is an IGCSE problem, so it should be, hopefully, pretty straightforward. You should be able to solve it. If you want to have a go at this problem, like I say, yourself, pause the video now. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so the first thing that I wanted to do was to start by considering the hexagon and how I was going to work out the area of this hexagon. Now I know, because of the lines of symmetry, that a hexagon is made up of 6 equilateral triangles. Okay, now all the angles in the triangles, because they're equilateral, are going to be 60 degrees. And I only need to consider one of those, work out the area of that, times that by 6 to get the area then of the hexagon. Now I don't have any lengths at the minute, so what I'm going to do is I'm going to call these side lengths x. Okay, now obviously because it's equilateral, all these side lengths will be the same, so they'll all be x. Now to work out the area of this equilateral triangle, I could half the x and use Pythagoras to get the perpendicular height and do it that way, but probably the easier way to do it is use a half AB sine C, where C is the angle in between sides A and B. So the area of one of those triangles would be a half x times x times x times sine 60. So the area of the hexagon is 6 times a half times x times x times sine 60. Now when we simplify that, what we get is 3√3 over 2 x squared. Okay, now from there I then need to try and work out the area of this equilateral triangle and take it away. Okay, now I'm told that AB is 1.5 times PQ. If I change 1.5 to a fraction and AB to x, because that's what we've called x. X is the length of one of the sides of the hexagon, or any side of the hexagon. And 1.5 is 3 over 2, just because that will allow me to manipulate it a little bit easier. So from here, if I divide both sides by 3 over 2, that's the same as timesing by 2/3. I get that 2/3 x is equal to PQ. Now we know that PQR is an equilateral triangle, so we know that all the angles are the same, which means they all have to be 60. From there, I'm going to use the same method to work out the area of this equilateral triangle. I'm going to do a half AB sine C. So I am going to do a half times 2/3 x sine 60. And that simplifies to give √3 over 9 x squared. Now I can work out the shaded area in terms of x, which is 3√3 over 2 x squared minus √3 over 9 x squared, which I can simplify to 25√3 over 18 x squared. Now we know that the shaded area is 72√3. Okay, so what we need to do is write that as a single equation and solve that to give us x. So I can cancel the √3's straight away, and that will give me 72 is 25 over 18 x squared. Divide by 25 over 18, or, as I said earlier, times by the reciprocal, times by 18 over 25. That gives us x squared is 51.84. Square root both sides of the equation, we get 7.2 is equal to x. Okay, so you might think that that's the answer to the question, but remember, the question was, what is PQ? Now what we've worked out here is AB, which was x. It was the length of one of the sides of the hexagon. So we've worked out 7.2 is equal to 1.5 times PQ. Divide both sides by the 1.5 and we get 4.8 is equal to PQ. If you were able to solve this problem yourself and you had a different method, put it down in the comments below, please do that. And if you're not already, and you did like this video, drop a like on this video. If you're not already, as I say, please do consider subscribing to the channel, because I upload a new problem solving video every Monday at 5 p.m. and in the run up to the GCSEs I'm trying to do as many problem solving geometry based GCSE problems as I can to help people. And I am aiming to upload weekly my work solutions as well to IGCSE Edexcel past papers, because that's what I teach currently. So if you are interested in that, again, consider subscribing to the channel. Thank you so much for watching. Have a great week, everybody, and I will see you next week for another problem solving video. Till then, bye bye.